We are going to do from the week 8, the quiz 1, that says that two identical loudspeakers are placed on a wall 2 meters apart each one of each other, and that the listener stands 3 meters from the wall directly in front of one of the speakers. This is a scene from the up. And it also says that a single oscillator is driving the speakers at a frequency of 300 Hz. Now, the first question is, what is the phase difference between the two waves when they reach the observer? And the second part is, what is the frequency closest to 300 Hz, to which the oscillator may be adjusted so that the observer hears minimal sound. So for the first one, for the phase difference, we first have to take this, that is the other speaker, to the kid, like the X2, and this one like the X1, that is the direction of the other speaker to the man. So we have to get this, and for this we know from Pythagoras theorem that X2 is equal to 3 to the square plus 2 to the square, and this is equal to 3.60 meters. Now this is X2, and now we have to use the formula that we know, that is velocity equal to wavelength times frequency, and the other one, that the phase difference is equal to 2 pi difference of x over the wavelength. We need the wavelength, so we derive from this. Wavelength is equal to velocity over frequency, and this is equal to the velocity of sound in the air, that is 343 meters per second, over the frequency, that is 300 Hz. So the wavelength is equal to 1.143. And now we substitute everything here, so this is 2 pi x2, that is 3.60, minus x1, that is 3, over 1.142, and this is equal to 3.30 radians. That is equal to the phase difference. And now we know that it has to be a destructive interference, because we want to hear minimal sound, and we are going to equal this to destruct the 300 Hz. So we know from destructive that the wavelength has to be 2 times the difference of x, and we also know that velocity is equal to wavelength times frequency. Now we have to find the frequency, so that the closest to 300 Hz, so that the sound is well destructed, and we derive from here, so frequency is equal to velocity over wavelength, and this is equal to, we substitute this here because it is destructive, this is velocity over 2 difference of x, and this is equal to 345, that is the velocity of sound in the air, and 2 times the delta x, that was 360.60 minus 3, and this is equal to 343, 2 times 0.606, and this is equal to 283 Hz, and that's it.